Okay, good morning. Actually, very, very early good morning. Appreciate everyone coming out at such an early time. Obviously, everyone's got a very keen interest in cognitive services. We're going to bring you through Azure Cognitive Services in a bit of a deep dive, a couple of deep dives actually. So cognitive services is very broad. There's lots of different components to it. So we're going to bring you through an overview of everything, as well as a bit of a deep dive on two of those. But what I wanted to do first is give you a scenario that hopefully starts to glue together how these things could work. So think about a terminal in a shopping centre. Maybe it's outside of a travel store. Someone comes in, it's been a long week, my boss is on my back, I've had a long, hard go at this project, I need to get away, I would like to book a holiday. So what does this terminal know about you? It knows you're 35 years old, it knows you're male, it knows that you spoke English, it knows that you're unhappy, it knows that it's actually seen you before because it recognises your face, it recognises your voice, it knows the context of that previous contact. You actually asked for directions to a different store within that same shopping centre. It also recognises an image on your t-shirt, which is the image of a beach. So what does it say to you? Good to see you again. Would you like to go somewhere warm, have some fun, such as the beach? So off you go and have a conversation in English with this service, where it continues to provide search, sentiment, tracking your sentiment as the conversation progresses through speech and text, as face as well, and provides recommendations to you. At the end, fantastic, that's great, book it. Pay with whatever payment method you want to use. It then recognises that the sentiment has increased from the first point of contact. So what does it say to you? I'm glad it could make your day better. Have a good time next week. Welcome to the world of cognitive services. And this is exactly what we're going to be talking about today. So who are we? Rolf is my name. I'm what's called a data solution architect. I'm from Melbourne. What does that mean? So data solution architect is effectively anything that's data in the Azure cloud. Do you want to introduce yourself as well, Chrissy?
Hi, I'm Christina Runn for Chrissy. I'm a data platform solution architect. I'm also Melbourne based. What that means is where Rolf is Azure based, I'm everywhere data, so I do on-prem as well, basically.
Cool. There's our contacts on LinkedIn, and I have a blog as well. Feel free to reach out to us on LinkedIn. Just let us know that you came to our session so I know who you are, so we can sort of hook up with you. Okay, this is our session agenda today. We'll bring you through a bit of an introduction of what is cognitive services. I'll bring you across all the suite of services. We'll actually talk about how they're going to be used, how to deploy them. We're going to deep dive into two. We just can't do them all. I'd love to do them all, but we can't. So we're going to deep dive into two. Text analytics and Lewis. You may have actually, in the keynote yesterday, both of these had a bit of a prelude to both of these. So we'll actually bring you through how these work. And then we'll also a bit of a wrap up at the end as well. Happy to take questions as we go through. We have a lot of content. We might deflect a couple to the end if necessary. All right. I think a lot of people have heard of Cortana by this stage. If you haven't, here's the diagram that effectively describes what it is at a very high level. The way I like to describe Cortana is effectively a brand name, a branding, a marketing term that pulls together a whole stack of services in Azure that tend to work really well when you deploy them together. Absolutely can be deployed independently, but tend to work nicely when sort of co-joined together and deployed together. These are those services. They sort of cover off about 4 different pillars. So moving from information management, think about ingestion into the cloud, collection of data into the cloud, through to data stores, in this case big data stores specifically, data lake and SQL data warehouse, some great sessions here at Ignite about those two, into machine learning and analytics, so actual machine learning, data lake, these sorts of things. We're across this side, we're in the intelligence part of Cortana. We're going to be covering off 2 major areas, cognitive services and the bot framework. There's actually 24 different services that cover cognitive, of which are made up of multiple APIs. Okay, so APIs, Keep that in mind. Everything you talk to in cognitive is through an API. And it's actually growing. Last couple of weeks, there's been a few added. I'm not surprised that they'll continue to evolve as well moving forward. This is them. These are the cognitive services, the cognitive service APIs. Vision, speech, language, knowledge, and search. So just think about if vision, for example, so computer vision, emotion, be able to detect what you feel by looking at you, identify your face, even moderate images. It's pretty cool stuff as well. Recognize who's talking. Language, translation, Lewis, which we'll talk about, text, which we'll talk about. And then knowledge as well, such as recommendations. If you think about my example, in the example I gave at the start, we only used 9 of the 24 cognitive services, 9. Only 9. Think about all the other things you could do with these. So it's getting bigger and bigger all the time. The best thing to do is actually look at a demo. And to do that, in case you weren't aware, we've been monitoring you the whole time. So anyone on this side of the crowd is actually, we can see you guys here. So we've got a couple of 39-year-olds, a lot of guys on this side. Your age is flicking up and down, perhaps the light's affecting the quality of that view. It's also recognising your particular happiness, your surprise, whether you're stunned, whether you're not, whether it's seen you before. That's the interesting part. So it identifies not just the number of people, the number of presentations, but not only that, but the unique number of presentations. So it recognises you and remembers you. That's the important part. I only picked up one female on this side. I'd say it's probably one person here. So there you go. So cool stuff. What are we looking at here? This is the intelligent kiosk. This was presented yesterday in the keynote. In the slides here, I've got the links to not only the download for the Windows 10 app, but the code to do it, the GitHub code to do it. So anything that you see in the cognitive services space that's provided by the intelligent kiosk, you can actually get this and do that yourself. Grab the code and actually try it out. This is only one of the many, many examples. If I go back, lots and lots of different cognitive services demos in the intelligent kiosk, such as Bing Analytics, which I'll show you in a second. How old? Many people heard of How Old before? Website that actually showed you how old you were. Yeah, cool fun. This actually, the real-time crowd insights pulls together a lot of those services and displays that in one sort of coherent place. So we've also got a lot of other things we can do. We can analyze video, do a lot of fun things as well. What I am going to do though, I'm going to switch to this side. I'm going to show you I'm not going to switch to that side. There we go. Zigged when I should have zagged. Okay, so this is the Bing News Analytics. So if we want to do something like Ignite Australia 2017. There we go. So what this is going to do, it's going to search off to the web using one of the APIs and pull back anything where those particular terms are actually present or part of those terms. The colour of the icon, each one of these is news articles, by the way. The colour of the icon is the sentiment. As you start to scroll down, you can see it gets slightly more darker and darker, and all of a sudden it's red. So the sentiment of the article in all up starts to degrade. So you can have a quick look at this particular article is about this particular news item. Overall, the sentiment of that article is a certain rating from 1 to 0, 0 being very negative, 1 being very positive. And you can actually start to have a look at the actual skew of those articles, whether they're positive or negative for that particular term. This is pretty important. I'll show you another demo on this in a second around how we can use this in kind of interesting and fun ways with data that you're already producing in your business. So I wanted to kind of set the scene around how the Cognitive Services APIs can be used, kind of in a fun example. There's the link. You'll have the slides later on, including the actual GitHub code. You can do it all yourself, develop it yourself. So where can I find these things? Okay, so they're in Azure. They're in the West US region only at this point in time. Bing's kind of all over the place. They're currently in preview. Some of these things are dropping into GA pretty soon though. How do I deploy these things? So you go into the Azure Management Portal. I'm not going to demo that. It's pretty straightforward, and I'll show a screenshot. You can do it with Azure Resource Manager templates or a REST API to deploy an API, which is pretty full on. So what do you actually get when you deploy these things? The Cognitive Services APIs are PaaS. There's nothing that underlies, there's no servers that's deployed. It's multi-tenanted, so it's a shared environment, and it's PaaS. Keep in mind their APIs. When you do deploy them, you get a key. That key is your access to use the API. So you'll get an endpoint. Here's your URL, an endpoint that you can use. You'll have a key that allows you to get to that endpoint. That key binds your access to that API to you. If you give someone that key and they use those APIs, you will get billed. Okay, so I'm never going to give you my keys. Keys are unique to you, and the endpoint is publicly available. It's publicly visible. Okay? So that, of course, begs the question, how do you communicate with it? Here's an example of one of the ones which is the emotion, an example of how that URL is broken down. Of course, it's secure, HTTPS. All communication is done through HTTP, so it's a request-response process. Has a base URL, an API, a version or not. Most of the APIs look like this, so it tends to be quite explanatory of how they're broken down and what component you're using. When you call them, you have to provide a header. That header's got your key. Okay, so have a request to the API, you pass a header, and you pass a payload, which is a JSON request. It's a formatted JSON request. We'll show an example of what this looks like. When you talk to it, you'll get a response. Of course, it's in JSON. And also, you'll get one of many different types of response codes as well. The key ones, though, are these kind of two at the bottom. You're out of your quota, which can happen if you're using the APIs a lot, or your call rate's exceeded. What does that mean? It means that a lot of the APIs have a limit on how often you can call it, a number of calls per second, for example. That increases the higher the scale that you choose to deploy. I'll show you what that looks like. Before we do that, though, what are some use cases? Lots of different places that these things are being used today. Uber's using it for driver identification through Face API. The one I like is actually the top one, which is bringing together some really cool stuff and actually helping people, helping vision-impaired people, which is something else, just something else. But just imagine other places these things would be used. Imagine in a trade show, monitoring the crowd as they come by, recognising the response that the crowd has to the products in the window. Imagine finding lost kids at, say, a shopping centre, so looking for face identification of those children throughout the entire shopping centre. Or imagine in a nightclub, or even a bank, looking at male to female ratio, for example, at the nightclub, looking for the members as they come in, identifying their members, looking for people that really shouldn't be there, who are actually a security risk. So pretty cool stuff. Let's talk about the Text Analytics API. When I say Text Analytics API, it's actually four separate APIs. The first one does sentiment. It can talk in English, French, Portuguese, and Spanish. I don't know exactly why those languages were chosen. That's what they have. So what it can do is you can pass it some text, and it will grade the text for the sentiment, whether it was positive or negative, 1 being very, very positive, 0 being very negative. It can also do this thing called key phrase extraction, and it does this in a couple of different languages as well. Different API call under the Text Analytics banner. Extracts key phrases from text, and it's best shown by an example, so I'll show you what that looks like in a second. It can also do a thing called topic detection. This one's kind of interesting. The first two, all you need to do is send it one single piece of text in the format of JSON. This last one here, this middle one, the third one, I should say, you need to send at least 100 pieces of individual text, 100 documents. The reason it does this is, what it can do, it can scan through all the documents. Perhaps it's call center logs, so the transcripts of call center logs. Scan through all of those logs, identify what are the general topics that people are talking about. This one seems to be about the Ignite conference. This one seems to be about complaints. And it starts to group them together and bind the documents to say, 25 people of the 100 are talking about Ignite, another 25 are talking about complaints, another 25 are talking about something else, for example. So really cool stuff. So the question was, can it tell you the time of the day? So can it tell you the time of the day that topics come up? No, it can't. It's effectively, when you call the API, it's a very structured format, and I'll show you what that format looks like.
You do it programmatically, though.
You can capture it in your application and tag it, which is actually really important. I'll show you why that might be in a second. And also does language detection. So all these other ones here, you need to be talking to it in a certain language, but this one can detect up to 120 different languages. You send it some text, you say, what language is this? And it will tell you what it is. In case you're wondering, the sentiment in particular was trained on this thing called Sentiment 140 data. So that's a publicly available data set of millions and millions of tweets that a lot of different sentiment engine uses. Microsoft's no different. In addition to that, they also did, I don't have visibility on it, but they also did a lot of other additional value adds to the sentiment engine on top of that Sentiment 140 data set. This is what it looks like when you deploy it. You go to the Azure portal, you say, please deploy a cognitive services API. It's going to ask you a couple of things. It's going to ask you, well, what do you want to deploy? Give me the text analytics API, please. I want the West US location, only one location at the moment, and a pricing tier. Pricing tier, okay. There's a 50% discount while they're in preview. This is your only lever to scalability. So we have a free tier. And matter of fact, all of the APIs have a free tier. So everything that you've seen today, you can actually do for free to try it out yourself. As you start to scale up through the different standard tiers, S1 to S4, your scalability of the service increases quite dramatically. If you start to hit your rate limit, what do? Well, you deploy another one. Pretty simple. That's the service tiers, relatively simple. A lot of the APIs have a slightly different pricing model, but fundamentally work off a tier model. Let's have a look at the demo. Okay. Okay, so what we're doing is we're going to the demo page for the Text Analytics API. And what we've got here is we can say, what happens if I send some positive text through in English to this API? Okay, what's just happened? Behind the scenes, that's called the Sentiment API with that piece of text. And it's basically said, I'm pretty sure this is English. As a matter of fact, I'm 100% sure. There are a couple of key phrases in this. Wonderful experience, rooms and staff. They're the key phrases which have been extracted by the key phrase API. The last one's a separate API call, three API calls here. Detecting the sentiment, sitting at around 98%, so incredibly positive. That's a very good question. Does it invert the confidence when you start to change the way the text is put together? Absolutely. As a matter of fact, I'll show you an exact example of that. So I'll just show you some English negative. Terrible hotel, food was awful. What happens here? Terrible hotel, staff, food, key phrases, terrible sentiment. Don't stay at this hotel. What about Spanish? Spanish positive. Anyone speak Spanish? Cool. 76% in Spain. What about if we start using our own text? We are having a great time at the conference. Exclamation mark. We are having a great time at the conference. Great time, conference, 98%. English, definitely. What about if we do this? Very subtle change, full stop. 95%. Great time at the conference. Great time at the conference. So very, very subtle changes can actually change the sentiment, not dramatically, but enough to maybe shift the way that people think about it, that particular statement. What about we're not having a great time at the conference? Which I'm sure is not the case. We are not having a great time at the conference. Conference, 42%, that's not so good. We're Australians. We talk weird in funny ways. We're having a great time at the conference, not. Subtle. Not entirely positive, as it was before, 98 to 74, with a very subtle change. Still doesn't exactly understand the way this is put together, but it recognises it's still not as positive as potentially it should be. So it's really cool stuff what you can do here. Then we've got other things such as this. We're having a great time at the conference, but the food and the weather are bad. Just for the record, the food and the weather are actually reasonable. So 77%, food, weather, conference, 77%. I'm going to hold fire on this for a second because there's something interesting around the way that we've analysed this text that I think you need to know, and I'll show a specific example of why you need to be aware of multi-sentence statements. Okay? I'm going to flip back. Oh, before I do flip back, that's only one way you can start to interact with these APIs. So just keep in mind, this is just a simple demo page. You want your own code, you want to code this yourself, there's the link. Copy this code, put your key in here, put your text in here, and you've got your own sentiment engine that does sentiment, key phrases, I think it does languages, yeah, languages as well, right there in the code. So pretty cool stuff. So what just happened? What did we just see? We just saw 3 different calls to these 3 different APIs. Sentiment, key phrases, and language. We sent a JSON request that looked like this. We sent, or in this particular case, it's only one document. We are having a great time at the conference, however, the weather and the food are bad is one statement. A couple of key points here. This can be sent as single document, so a single piece of JSON here, just this top part. But you can also send it as a batch. The ID that you send through is actually really important. It's the key that the text analytics service uses to identify the text that's sent to it. So once you send that text, it's never going to send you that text back. It's just going to send you the ID back and say, this ID had a sentiment of X. So you need to know and remember that ID that you sent. It has some limits, as you can see here, maximum single document size, single request, and rate per minute. If you exceed rate per minute, just deploy another service and use 2. Better sentiment outcomes by breaking text into sentences, and I'll show you an exact example of that. So when you call it, what do you get back? When you call the sentiment API, this is what it returns to us. That's translated by that web page. ID1, you have to remember what ID1 was, 0.934. We are having a great time at the conference. ID2, 0.176. That's a sentiment. 0, negative, 1, positive. When you call the key phrases API, you get this. Key phrases, great time and conference, ID1. ID2, weather and food. The cool thing about this is, because you know the ID, of course, it's your application that's doing the calling, you can then start to say, ID1, we are having a great time at the conference. We can now say, conference has a sentiment, its key term of conference has a sentiment of 0.934. So very positive. You can start to build up key phrase word clouds that show very positive or very negative sentiment about the key things that people are saying about the text. The last one is language. So when you call the language API, 0 likely, 1 certain, I'm absolutely certain that ID1 was English, and same as part 2. Let's break this down for a second, that example I gave. Why score sentiment by sentence? Okay, we're having a great time at the conference, weather and the food are bad. So when we put this out into slightly different sentiment score, when we put this out into the sentiment engine, you could probably argue this is misleading. Conference, weather, food, forget great time for the moment. It's actually saying it's neutral. I think it's a little bit misleading. So what you might do is do this. Let's send it as two separate calls. When we send the first sentence, conference, very, very positive. In fact, incredibly positive, 0.95. Second one, weather and the food are bad. Weather, food, very negative. So this is just an example where you can start to say, previously weather and food was actually, oh, that's actually pretty neutral. I'm pretty happy with the weather and the food. In reality, it's not. So you need to be aware of, have a think about the way that you break down your text. Honestly, you need to test it with some of your own text. There's always going to be ways, certain types of text that will flow either way. And you can break this down with just regex, regular expressions can break down sentences like this. Matter of fact, there's a lot of code that has regex to do this already. So pretty cool stuff. Does that make sense? Do hashtags affect the way that the API responds? Yes, it does, absolutely. So if someone has Twitter context with hashtags, they can affect the sentiment, as well as URLs. Yeah, for that reason, you might want to strip those out too. So, nice one. Is there any way to? Yep. So is any way to train the API? And the answer to that is, at this point, no. So in the future, potentially. Yeah, it's a good point though, because what you might find is for your type of text, it might start to skew the response. You know, I want to train it to say this is kind of positive, not as negative as you think it is. Yeah, very good point. It's coming though. Okay, let's have a look at part 2. Topics. I left topics to itself because it's a little bit more involved. So what does it look like when you call this API? You send it a very, very similar document we had before. A big key difference. We have these things called stop words and stop phrases. This particular API allows at minimum 100 documents. You must have 100 documents to talk to this API. Certain types of send rates and maximum document sizes. There's some issues around that potentially if you want to scale this up. But the key points around these stop phrases is these terms I don't want to turn up in a list of topics. So what does that exactly mean? When you talk to that API, and I'll hold fire on that for a second, this is what you get back. You don't get an instantaneous response. You get an asynchronous response. You talk to the API and it says, fantastic, thank you for your document. Here's an operation ID. Come back in a little while and I'll have your answer for you, because it's got 100 documents or maybe 1,000 documents to process, right? So you have to talk to this API, constantly throwing this operation ID to it. It's going to say, not started, running, finished, succeeded. When you do get succeeded, you get this JSON response. 2 major components. Has a list of topics and a list of topic assignments. So what does that mean? The topics are effectively the key phrases of the conversations. So think about hundreds and hundreds of documents, transcripts going through into this API, and it realizes, I think quite a lot of these people are talking about the Ignite conference. It has a score of 2 saying, I've got 2 documents assigned, saying I've got at least 2 documents that are related to Ignite conference. You may have hundreds, for example. The second part of it's basically saying, for the documents that you sent me, which are the ones that are assigned to that topic? In this case, I've got 2, just in my example, ID1 and ID2. They also have a score. This time is called the distance. The distance effectively means how close or how far that particular document was to the topic in question. So in this case, we are having a great time at the conference, very close. In this case, it's actually 0 was close. The second document, much less so. So you can imagine hundreds, thousands of these documents coming through, being graded and grouped into topics, and then assigned to these. You can start to build up some really cool things, great visualizations around ways that people might be talking to your contact center, for example. Really cool stuff. A lot of fun. Okay, what can we use these things for? You saw some use cases for cognitive services broadly, but what about the text analytics API? Well, we've seen a couple of people use this for, again, contact center apps where they might have a call flow, a data pipeline. People start to talk to the contact center agent, translates that into text, grades it with Sentiment API live, and as the conversation with that customer progresses, you might see the sentiment drop off. When the sentiment drops off, that could create an alert to the manager to say, this conversation's going south with this agent, I think you need to jump on this call. That can be automatically graded for you. Pretty cool. Lewis and bots, I'm going to leave that to Chrissy. Social media data pipeline. Hold fire on that for a second because I'll show you what that looks like. And the last one, for people who like SQL Server, when I love SQL Server, you can absolutely embed these things right inside the SQL database as well through SQL CLR. And I've got a blog post on actually how to do that if you're interested. So you can embed Text Analytics API. If you've already got data in a table, you can call out to these APIs directly from the database. Kind of fun. So social media data pipeline. Okay, this is your homework assignment for today, should you choose to take it. That link down there creates for you from Power BI what's called a brand management template. Deploys in about 10 minutes. It's pretty cool. Costs about $6 a day for about 10,000 tweets in a month. Even the most avid political tweeter can't exceed that, I'm sure. And you can actually get an Azure subscription up to, I think it's $260. So that will cover it well and truly. So you can deploy this today, have a go, and it will deploy a couple of key parts for you that create what's called a data pipeline. So what does it do? A logic app runs every 3 minutes, calling the Twitter API, collecting handles or hashtags that you define that you want it to collect. When it does that, it calls an Azure function that calls the Text Analytics API, grades that sentiment for you of that text within the Twitter tweet, and stores that in an Azure SQL DB. You then have the ability to have a look what that looks like in Power BI. So visualize that, and I'll show you what this looks like. This is my little addition at the top, though. Why not tie in some cool sort of machine learning as well? You've already got Twitter sentiment. Perhaps you're tracking a marketing campaign within your business of a particular brand that's just been released. Wouldn't you want to track sales too? Wouldn't it be cool to actually do something like, as the sentiment increases about this product, we can actually see our sales increase as well and start to do some machine learning around predictive analytics around where that will go. If we change the campaign, how will that affect sales? If Twitter sentiment drops, does that affect sales? So pretty cool stuff you can do with machine learning there as well. Okay, let's have a quick look at this before I hand over to Chrissy. So what this does is a little link here to show you what this looks like for one I deployed before. So when you go to that brand management template, it will deploy something. This is a little customized one that I wrote. It will deploy something like this. What am I tracking? I'm tracking MSAU Ignite and the hashtag MSAU Ignite. What this is showing here is all of the authors that are tweeting and the number of times they tweeted, 117 for this person. Are you in the room here by chance? 0.67. So on average, they're actually quite positive about what they're saying, which is great. The top tweeter, of course, is Microsoft. These are the hashtags that have, in addition to MSAU Ignite, the additional ones that people are saying, such as Azure. 129 tweets that turned up, quite positive. 0.61, or neutral perhaps. What we're seeing here is the number of tweets and the average sentiment over time. As you can see, we're getting closer and closer to the conference. Boom, up it goes. And the sentiment is tracking, maybe even dipping a bit there. Hopefully that picks up over the length of the conference. This link will be live for the rest of the conference if you want to see it. It's in the slides. You'll be able to have access to that. Also got the ability to filter. So you say, well, let's actually have a look what it was like before the conference started, around this period. That's what it looks like. You can see who was tweeting and what they're actually tweeting about as well. Okay. Does that make sense? Yeah. So this just shows you an example of the Text Analytics API by itself. Okay, sure. But to answer your question at the back around, does it store time? This is the part that is important around storing time, because you have the tweet. You know when the tweet happened. All you need to do is grade it with sentiment. You attach the sentiment value to it and you store it, and you can start to see how things track over time, the number of tweets and the sentiment of those tweets as things progress. Is everyone cool with that? Okay. The look on your faces when I'm sitting up here is somewhere between, in the spectrum of fear to pity. I'm not sure. Yeah, somewhere in that spectrum. Okay. So what I'm going to do now, I'm going to hand over to Chrissy. She'll take lead from here and talk about Lewis, okay, and also integrate a little bit around text analytics as well. Anyone who wants to learn more about this, wants to break it down, wants to see some more demos, fantastic. Just hang around at the end. All the links are in the slides. Everything you've seen today you can do yourself, and you've got a lot of the code for as well. All right, over to Chrissy.
Hi. So who heard of Lewis before keynote yesterday? Oh, wow, that's impressive, really impressive. Actually, it was a funny story when I was doing the research for this presentation. I typed in Azure Lewis, and I found a guy in Ghana called Lewis Azure. He's in the Ghana Cocoa Board as a nurse. We're not talking about that Lewis today. Okay, so, oops. Okay, so what is Lewis? What Lewis is gives you the ability to train a model in order to detect intent in sentences. Why is that important? Okay, it's important because then you can wrap workflows around it programmatically in order to do stuff. So for example, I'm going to be talking a lot about a hotel concierge in this demo. So what you've got, we'll have a chatbot and somebody write, I want a towel. Lewis, you train it to understand that sentence in order for the Lewis to understand that it's a person who wants something and it's going to go to housekeeping as a result. So the number one thing that you need to do is when you're training Lewis bots is you need to understand, well, what are you asking? What is the intent? After you understand the intent, then you can build out your entities and then you can start building workflows around it. Is that all making sense? Okay. So, understand what your users are saying and then you can build a workflow or a conversation around it. Again, with pricing, we're limited at the moment on the standard plan to 10 transactions per second, which is still pretty good. But again, it's in preview, so it's still an evolving product. Okay, so when you build out Lewis, it's a RESTful API, and again, very similar to the way Rolf talked about his text analytics APIs, it follows the same format. So you've got API Project Oxford, then you've got the Lewis, so we're calling the Lewis API. So that could be text analytics, it could be sentiment, but for this instance, we're calling Lewis. The version, because we've got version 1, version 2 has just come out. Apps means that we're actually going to call the API to detect intent. So there's a whole heap of other things you could put in there in the apps. You can actually build, train, and create Lewis applications just using the API. The application ID, which is very important, so that's, you can have multiple applications inside a Lewis subscription, I'll show you that. Each one of them has a unique ID, so it has to understand which application it's calling, and your subscription key. Right at the end, you have the sentence that you're actually passing through Lewis. So this is what it ends up looking like. I've actually obfuscated this and put my own numbers in, so don't try and use this one. But also what you can see is we've had to encode the sentence. So can I have some water with a question mark? So we've got %20s for spaces. There's some encoding apps out there if you actually want to do this programmatically. Okay, so this is what the response, I've actually broken it up into 3 bits. Is the first thing it does is right at the top, it thinks that you're asking for an order. So see that 0.94% number? That's it saying, I'm 94% sure that this is an order in. Okay? And then it breaks down. Over here, these are all of the intents that are in the model, and then it gives each of them a score. So you can see, okay, well, they could have been asking about the weather, but see, that's a 2e to the -6. So I'm really, really, really sure that they're not asking about the weather at this point. And maintenance is the same. So it's, what is it, 6 zeros that way. Okay? Then what it does is it breaks down and finds the entities that are in that sentence that we want to track. So in this situation, I want some water. We've actually tagged it as a room service food item. So then we can push this output and notify room service to go and bring that person some water. Does that make sense? So understanding the JSON output is critical in order to write programmatically what you're going to do next. Okay, this is what the actual interface looks like. This is just a picture. I'm not going to spend any time on this because I'm actually going to show it to you for real. So this is my front end on Lewis. So it's lewis.ai is the user interface in order to use Lewis. We've got some things up here. If you want to build a new app, you just press new application, or you can import a JSON file from an existing application and it'll build it for you. we've got something here called Cortana built-in apps. Now, these are ones that we've actually built. You've got to choose your subscription key, and then if you write a query, will I need a jumper today? So there's some specific, so here, we've built around the Cortana personal assistant. We've pre-built some existing applications. This is the output. So if you notice, will I need a jumper? Zoom in, thank you. Thanks, Rob. Thanks for the reminder. So will I need a jumper today? It's worked out it's a weather question. And this is the entities that you can pass into your Weather Bureau of Meteorology application. Okay? So we've got a lot of, if you see here, we've got the documentation page, and it can take you to all of the pre-built stuff that you can do. We've got encyclopedias, celebrity lookups. Oh, that looks horrible. There we go. So there's a lot of, this is the documentation page. So these are all the pre-built in stuff that you can do. Okay? All right, we're going to move on. Okay, so here I've got two applications. I'm going to, this one is around flights, but this one here is a special one. It's got this very, very long name because I've created it using the Microsoft Bot Service Preview that has been built. And I'll show you that later, but right now what we're going to do is we're just going to go in, we're going to edit this application, and I'll show you what it all looks like. Okay. So down the side here, you've got your intents, your entities, you've got some pre-built entities, and then these two here are kind of advanced functions that help the models run faster. Okay? So the first thing you do is when you're building something, you want to know an intent. So it might be a room service order or a house cleaning order or some maintenance orders. So if you want to build out an intent, new intent name, check flight, for example. That's something that a hotel concierge would do. You'd ring up your hotel and say, can you check to see if my flight's on time? Or you just do it yourself, but for the purposes of this demo, we'll run with it. Now, an example of the command that triggers this event would be, is my flight on time, for example, okay? So right now we've built a new intent. So here it said, okay, this is the check flight. I've got a choice of changing it to one of the other intents. And I can also highlight words in here and go, actually, this is a room item, this is a food order, a drink item, a room item, and then I can just click submit, and then it goes into the model, okay? Or we can start adding new ones. I would like 4 coffees.
Make it 5.
I'll make it 5.
What's your zoom to on that?
Oh, thank you. Can everyone see this?
That's a bit better.
Better?
Yep.
Okay. I would like 5 coffees. So straight off the bat, what it's done is it's looked at it and it's got highlighted this number. So what it's done here is it's added, what we've added to this is a pre-built entity. So it's color-coded so I can see what it's highlighted. I can highlight this and go, this is a food item. And what I'll also do is a special one, which I'll talk about. I'll highlight the 2 of them. If it's going to work for me. And I'm going to say this is a food order. Oh, I'll remove that. And this is a special entity which is called a hierarchical entity. And I'll show you this in a second. Okay? And then after that, I'll make sure that I specify that it's room service and I click submit. So what we're going to do is you're going to end up building up a series of intents and entities based off sentences. So here, these are the entities that I've added. So I've got food items, drink items, room items, and room number. I can add a new entity name, which might be maintenance item. Just say I've got bad plumbing. And I can also include children. So here you can have hierarchical entities, which you can build up based off anything, but you could have a hierarchical entity based on room number. So floor 15, room 7. So it would build up into 704, for example. So you could build a hierarchical entity based off that. Or you could build a hierarchical entity, date, time. I've actually, in other examples of this, built up a hierarchical entity based off, okay, this is a house cleaning item, and under house cleaning, we're going to have things that we want fixed, like a make the bed, turn down service, clean my room type stuff. So you can build out hierarchical entities. The other one is a composite entity. Composite entities are what these two are. So, for example, a food order would be a combination of a number and a food item. And that creates a composite entity, which would mean it's a food order. Does that make sense? Am I explaining this well enough? Yep, perfect. Okay, I'm not going to include children. I'm just going to make this a maintenance item. And then, after we've added it, we've got another little colour-coded item here. You can click on these. So here, my food order, you can tell it's, here are my children. So I've got number and food item. I can change it. So I've got a drop-down list. I can add extra children to it if I want. So I can add drink items to the food order as well, for example. I'll just delete. And then we have all of these pre-built entities. So these are the ones we've built for you. And they do such things as ordinals, temperature, dimensions, monies, geographies, got an encyclopedia, percentages, date times, emails. These are ones that we've built for you, so you can just use them. But the very clever thing with this number is, for example, I would like a wine. See, it's actually highlighted it as a number. So it's clever enough to work out that means 1. Okay? And then from here, and I'll just keep bringing this out, that is a food item, and the two of them together make a, damn it, it's not working for me today. Two of them together make a food order. So we've created a composite entity, and you notice it's put little square brackets around it. And then we have to say, okay, make sure that this is a room service item. Okay? So those are our entities. Those are our pre-built entities. Now then we'll talk about these two. So we have our regex functions. Our regex functions enable you to build up, and we'll click on it just so you can see. So you can use regular expressions to build up repeating patterns, which might help things run faster. So room number I've used. So here, if someone types in, I'm in room 7, and then we tag it later on as a room item, if somebody else comes in and says, I'm in room 70, it'll still recognise it as a room item and automatically tag it in, because the regex helps it work it out faster. Does that make sense? So in this particular example, does anyone understand regex? Oh, good. Lots of nods. So we've got lots of people will either go RM7 or they'll go room 7. So we've got R, we've got an O dot. The dot means 1 or none, I think. I might have done this wrong. So we've got R dot, and then M. And then we've got a space, and \D plus means 1 or more numbers. Actually, I think this should have been a question mark. I might redo that. And click OK. The other thing to take note is that automatically, when you're passing things through regex, it automatically makes things all in lowercase. So you don't have to worry about case sensitivity. The other thing that we have down here is phrase list features. So with a phrase list feature, for example, I've created one called drink. These are words that are interchangeable that you can just use in the model. So when somebody asks for a beer, wine, whiskey, Coke or water, it understands it's a drink. And those words are interchangeable, so it understands them faster. Okay? So I've got one here for drink, and I have one here for food, and you can tell my eating and drinking habits are really unhealthy. Okay? Right. So, we have some intents, and in those intents, we've got some entities in order to work out workflow. What you can also do is review all of the ones that are in the system. So we've got, I would like a wine, I would like 5 coffees. So this one here that didn't work before, I can make that a food order. Oh, can I have a turn down in room 7? So these are the type of questions that people might ask over time. So we're happy with this. What we're going to do now is click this little button down there here that says train. So now we're actually going to train the model. We're training it in the background. It's creating an algorithm. Oh, okay, so I need more maintenance. Somebody got a suggestion. Please make up my room. Let's see if this trains this time. Oh, there we go. And then we can click publish. So when we publish this, it's going to create, this is your URL that it's going to create for you. So it's sitting on the back of the Azure Web Services. You can enable a Bing spell check on this. So as people are entering queries, it'll correct them using the Bing spell check API. And you can enable action binding if you want to bind actions to intents. So can I get the weather? You can actually bind an action for it to go out and get the weather from a service, for example. But we want to test this, so we're going to go, can I have some water? And from here, we can just click on it, and it comes back with our intent. Thank you. Oh, and in this particular instance, it didn't understand it, so it's put it in the none bucket. Okay? That is very, very important. So anything that it doesn't understand, it puts it in the none bucket, and then you can come back in, you get a list of intents that it's with suggestions, and then you can re-add things to it. Okay? Yes?
Do you do that for every language, do you? Or can it translate, if you do all the regex and everything in English, will it translate to other languages?
So the UI is English only, but Lewis itself can understand multiple languages. So if somebody, instead of saying, can I have some water, you could have something in Portuguese, or actually I think it's similar languages to what Rolf was saying before, so something in French. Je voudrais une glace du chocolat. I'm good, that's the only French thing I can say. Can I have some chocolate ice cream? And then yeah, so you can train it on other languages. Okay? Right. So, and then it's publishable. So now this web link now is live, and you can start publishing that in your applications in order to get details back. Does that all make sense? And then over time, I'll come back to this. This is your suggestion bucket. So anything that it doesn't understand, it ends up in the suggestion bucket so that you can retrain and enrich your algorithm. So think of Lewis not as you do it once and it's done. It's a program. You're constantly coming back, fine-tuning it, adding stuff, making it better, and then over time you'll end up with a really, really rich interface. Good enough that overseas people are using it for fast food drive-ins. So instead of going up and somebody trying to listen and understand, they have LewisBot listening to people talking into the speaker, and it's building the orders automatically. So it can work quite well over time. Okay. Oh, can it do spam detection? Not in itself. So I'm not sure how you would handle that, but I'm not. It depends on the spam, I guess.
If you have an app, like
Yes.
Can you detect that?
I think you'd have to wrap something around it. This is where something like the Azure API gateway could help. So it gives you a level of security above just open API references. So you might be able to do something like that. Sorry, there was another question. Yes?
I just wonder whether there are pre-built industry vertical sort of setups for this. Because people obviously, like in sales or automotive industry, would have set up a whole lot of patents that are going to be the same across that, or very similar across that vertical. Are they saved and then you can pre-use them, or people can collectively use that API to...
So the question was, is there industry vertical pre-created algorithms available? The answer is not yet. Because remember, we just got into version 2. This is still in preview at this point. It's going to evolve. It's going to change. We actually have, I don't know if you saw when I was creating entities with the action binding, it said this feature is deprecated. We're replacing it with something else. So right now, it's very new. It's changing. But Microsoft is going down the direction of creating industry verticals for stuff. So if you look at the Cortana Analytics suite, we have industry verticals there. There's no reason why we wouldn't end up having industry verticals here as well, but wait and see, is all I'm saying. Yes, question?
Does it train and pick up when you do conflicting regex in different phrases with, let's say,
So
doesn't know which one to go to?
the question is, does it pick up conflicting regexes if you've done something confusing in your regex? So what it would do, it would apply the algorithm to it, and you would get two. Remember how it says, this is my percentage of surety between the two. So you would get that. What you would have to do is come back and review and say, okay, well, this one I wasn't sure about, and you could change it.
If you have two intents, like I would like a glass of water and my room is 5 years,
Yes.
would he put 50-50 or would that
Okay, so the question is, if somebody puts in 2 sentences, I would like a glass of water and I need my room cleaned. How does it cope? So what I would do is programmatically break that down into 2 before sending it to the Lewis API. Very similar to what Rolf was talking about with the sentiment analytics, because those are 2 conflicting things.
But if you don't break up, he would give you a 50-50.
Yeah, it would be confusing. You need to have 1 intent per sentence, otherwise it's not going to work very well. Or programmatically, I mean, there's ways. All of this is all just JSON built with a programmatic output. So if you're clever enough to write something and go, okay, it's 50-50, there's 2 things here that it could be, you might want to deal with both of them. There's ways and means around everything. More than one way to skin a cat. Sorry, is there any other questions?
Is there an API for training it or just the user interface?
There is an API to train it. So remember at the beginning I said, at the moment it says apps. There's a whole slew of documentation on how to use APIs to test, train, create new utterances, create new entities. So you can do the whole thing via APIs. I think I might have to move on because we're going to be running out of time.
Come and see us at the end, though.
Yep. 5. Okay. Okay, so bots. Is everyone else as excited about bots as I am? So this slide is why I'm so excited about bots. So in the 1980s, people developed PCs. Everyone ended up getting one on their own desk and just started, using them, typing stuff in. I had an Amiga, so I spent half an hour writing, actually, a Commodore 64, half an hour typing a command this long to load a game up from tape. And it was 10 meg. Actually 2 meg, and it took half an hour. Then we got the internet. So people would do internet searches. They would use Google in order to search out where they would go on holidays or where they would buy stuff. Then in the 2000s, mobile came in and Apple turned up with their App Store. Now, I know I've heard people out on the marketplace talk about they left Google at that point because Google noticed the downturn in search. It impacted them. People, instead of going to the internet and started searching for stuff, they just used the app that they had on their phone. Okay? This is the next step. People aren't going to go to apps. People aren't going to be searching on the internet. They're just going to talk to their phone and say, I'd like to go for holidays in Vegas. Where's a good place to stay? And bots will be going out, getting the data, bringing it back, collating it, and helping to make those decisions. This is the next evolution in how people use technology. And Lewis is in the center of it. So, to help people get up and running, because I know not everyone out there are coders, and it's hard. It's daunting to just suddenly decide, okay, I'm going to do this. We've developed let's call it a bot as a service. It doesn't do everything. There's some definite little things that it does. You can choose it to be either in C# or Node.js. We've got some templates that will get you started, and we've got a built-in code editor. You can enrich them. So once you've got a bot, straight away you can publish it to a channel, which might be Skype. So is anyone using the TechReady bot? Yeah? No? The Ignite bot, sorry. Wrong word. Everyone has people started playing with the Ignite bot, and it's published through Skype. So that's one of our channels, but you can use email, you can use instant messaging, you can use a lot of different things in order to use these bots. It's built in the publishing to the channels for you. We also have, and you can embed cognitive services, and we've got a built-in web chat as well. Once it's published and it's working, well, what do you do with it? So because it's built on Azure services, it scales on demands. It uses the CI, the continuous deployment methodology, and it's all serverless code. So it's running off Azure functions. Does everyone know what that means? Yep, I've got some nods. So Azure Functions allows you to take a little bit of .NET or code and publish it to an Azure service. It's not actually, the hardware is invisible to you. So that's why we're calling it serverless. It just runs. So you don't actually have to put it on a host anymore. Okay, so I'm going to very quickly talk about something that I've built. So getting back to my concierge robot. We've built up a Lewis app that can understand intent and sentences. What are we going to do with it? So what we've got a web application. So just Azure Web App, which is just a web front end. Now it's going to go through an event hub. So when people enter stuff into a chat, this is our first in, first out messaging service. So basically what it does is it collects messages as it comes in. It's called like an event hub or a service bus. We got another web job which is processing stuff off that service bus. So as things comes in, it'll take the message and then it's going to push it through these cognitive APIs. So instead of having to have something that understands text analytics and intent, we're going to use the pre-built APIs. Also, we can use the speech-to-text API on the device as well. So the application, if somebody doesn't want to type, they can talk to their device. We can send something out to the speech API and it'll do a text-to-speech before sending it through the service for us. Okay, so in this situation, that is our bot. Does that make sense? So in here, I want a towel, comes through, hits the web job. The web job goes through and gives me a Lewis intent behind the I want a towel. It's a housekeeping job, needs to go to room service. Now then the web job has to decide what it's going to do with the output from Lewis. So this is where your logic workflow sits. Well, do I need to go back and ask another question? What room are you in? Do I have enough information then to process this out into another service bus to go out to notification services So my housekeeper gets a message to go to room 7 with a towel. Does that make sense? So this is how you can use all the different services to tie together to get an end-to-end workflow. Okay, so I'll show it to you. And it is, come on, here. Okay, so this is my concierge. I'm going to log in. This is a live website. If you want to, other people can log in too just to prove that this is a live website. We've had some interesting ones. So I'm coming to my live chat session. It's connected to the service. Just going to type in hi just to make sure that it's working. Come on. Ah, there we go. So this is an interesting message. Sorry, I'll zoom in again. I keep forgetting. We've received your request for service. Our staff will follow up momentarily. So this is it not understanding what to do with this sentence. So it's ended up in the none bucket for look at later. Okay? I would like a towel. Okay. Oh, hello. Okay, so there we go. We've just proved that this is a live service. So I would like a towel. This has come back as a positive sentiment. So it's hit the Text Analytics API, and I've got a thumbs up. And we've sent your request for towel to housekeeping. Now this is interesting. So if I go, can I have a towel? Just a slight change. It's not that smart. Can I have a towel? So obviously something's missing and it's given me negative sentiment. Okay? But it's sent my request for towel to housekeeping. Oh, and so somebody's coffee has gone to room service. Can I have a wine? Slightly different. I don't understand. This is why it's so smart. Obviously, I'm having a good time because I'm asking for alcohol. So I'm getting a positive sentiment on exactly the same statement as before. And again, my request for wine has gone to room service. So we've basically programmed my bot to understand the intents that are coming out of that sentence and then to do something with it so that the request gets routed to the right people. Yes? Good-o. I'm just going to re-log into here. So very quickly, I want to show you, so this is my pre-built concierge app. It's slightly different to the one I was showing you in the demo, but what I do want to show you is that this one's been running for a little while, and we have some suggestions. So if I look at the intent order in, these are all of the things that it hasn't understand. And you'll notice here that interesting list. So, sorry, thank you. Thank you for the reminder, I keep forgetting. So you'll notice here that this is what it thinks it is based on the algorithms that it's got. So it's giving me a suggestion, but I can change it to whatever else I believe. If I feel that it's actually, this is a weather list, I can change it. So I can continue training it based off the suggestions. So we've got some, let's go look at food items. Oh, there's nothing interesting in here today. That's annoying. But anyway, so what you do, you come back in here, you review the suggestions, you retrain the app, and then you republish it, so then it's smarter. So over time, you're going to be constantly improving your app. Yep, okay. Look, I'm going to move on to the bot service. So how do you build this for yourself? is the question. Where's this one? Oh, come on. This one. Okay, so I'm going to go to the Azure portal and I've pre-created a couple for you. But if you want to create a new bot, you click on here and bot service. So has everyone seen the Azure portal by now? Yeah. Okay, so here it is here. Your bot service, notice it says that it's in preview. Where's all of the documentation available, and then you click create. Okay, to create it, you've got all of these different things. So you'd be giving it an app, you'd tell it what subscription to run into, what resource group and what location. Notice Australia is here in the list, so you can create these bots in Australia. I'm going to go into one that I've half pre-created for you just to show you the next step. So after you've clicked create, you've filled out all of the details. You get a screen like, come on, this. So the first thing you need to do is create an ID. I'm just using my Hotmail account. Please don't look at my password. It was all dots anyway. Okay. So we've got an app. This will create me an app name. And what we need is the app ID. So we put that in here. And then we need to create an app password. Now this only creates once. So you need to remember this, note it down, keep it somewhere for future reference. It's the only time it's ever going to be displayed to you in clear text. Okay? I'm just going to make sure that I've got it. Again, I might put it in a notepad. Okay, so it is there. And then from then on, if you go into here, your application registration portal, it looks like this. So we have the password. So once you've got those details, then it allows you to go on. So you can choose what language you want to write your bot in. And these are all the different bot templates that you can use. Basically just repeats back what's entered into it. It's just very, very, very basic bot in its most basic form. They all have different iterations. These are the two that I'm very interested in. So we've got the language understanding one. This one will go off into your Lewis subscription and create an application in Lewis for you and then link it back. And then question and answer. Has anyone seen the Q&A bot? It's very, very cool. You point your Q&A builder at an FAQ, comes back with a list of, it understands the questions and answers, and then this will put a bot around it. So if you type in a question into a bot, it'll bring you the answer instead of you having to scroll through an FAQ. Okay, so we'll just do a language understanding. We'll create the bot. It'll take us to, I've got a minute and a half. So it'll take us to Lewis, but what I want to do is I want to show you this, what it looks like after it's built. So we'll go into the Lewis bot. Okay, so we've got the choice to configure continuous integration. And this gives us a design palette. So we've got all of the code in here. We can manage it on the fly. And then we've also got a chat window. So you can, from this palette, test it and work with the intent to see what your bot's going to look like before you publish it. So you've got all of your different files that make up your bot. You've got the design palette so you can actually code directly into here, and then you've got a testing phase to see what the output looks like. Okay? Cool. Well, that's my demo.
Yeah, absolutely. So last slide. Where to from here? So cognitive services, the key point we want you to take away is the complexity is obfuscated, it's simplified. You don't need to know or even have to care about how these APIs work from the cognitive perspective. You just need to know that they're there, they're going to scale, and when you talk to it, it will respond to you in a very, very timely fashion, in a very consistent way. So it's very, very simplified and commoditized. You don't need to have the smarts around how these things are built. The cloud's enabling this. So the cloud enables these things to scale, and you can do some pretty innovative things within your business at an incredibly low cost, and actually even try them all out for free as well. And the last takeaway is that applications are getting smarter. There's absolutely no doubt about it. If anyone went to the blockchain session today, applications are becoming quite autonomous, building up in very quite unique ways, and certainly when you start to integrate cognitive services and bots, they start to get very, very humanistic. You can talk to these things like you never have before, build applications you can never even thought of before. So quite cool stuff you can do. So they're the three takeaways: complexity simplified, scalability, and autonomous.
Also need to do a call out to go to the other cognitive services sessions. There's 2 left. So we've got Conversation as a Platform Part 2, which is today at 6:30 p.m. And we also have tips to coding a successful bot that aren't obvious, which is by Travis, who's one of our track owners. And that's on at, when is that on? Friday at 10:15 a.m. So, yeah, thank you.